Hi, I'm Tom Biebighauser with Wetland Restoration and Training. I happen to be standing in a wetland that I built over 20 years ago using the groundwater dam technique. I was shown how to use the groundwater dam technique to build wetlands by Earl J. Osborne, who was an expert heavy equipment operator who built farm ponds and fishing ponds and later wetlands with myself. And he showed me how the groundwater dam technique can be used to build huge wetlands at a reasonable cost or small wetlands at a reasonable cost. And the best part of it is when you use this technique, you're almost guaranteed success. So please stay with me as we take this journey and how to design and build wetlands using groundwater dams. One can use groundwater dams to build all types of wetlands. Here's an emergent palustrine wetland that we built using a groundwater dam. And here's a forested wetland that we built using a groundwater dam. The bald cypress trees you see growing in this wetland, we built this wetland 30 years ago using a groundwater dam. I've built thousands of emergent palustrine wetlands using groundwater dams. You're looking at scrub wetlands that have been built using groundwater dams. I used a groundwater dam to build this wet meadow wetland. Groundwater dams allowed us to build this vernal pond wetland. I'm walking on a groundwater dam that we built over 20 years ago when we constructed this wetland. And you can't tell it's a groundwater dam because there are willow growing on it, buttonbush, all sorts of sedges and rushes, and it's underground. But this is how natural wetlands are put together. They have natural groundwater dams, and what people did is they dug ditches through them and they put in buried drainage structures, and we disabled all those drainage features and we restored the natural basin, and now we have this beautiful natural looking wetland that should last for hundreds, if not thousands of years. The paint on the ground shows that there's been a check for buried utilities before digging. The different colors will show what companies have been out checking. There could be electric, there could be buried fiber optic, there could be gas lines, and all these things have been marked prior to digging, and it's really easy to make this check. All you have to do is go online or make a phone call. Building a groundwater dam is the most effective and the lowest cost way to restore or create a wetland of any type and of any size. Some people have other names for groundwater dams. They call them core trenches, keyways, cutoff channels, but no matter what you call them, they all work the same to ensure the wetland that you build will hold water as planned. The excavator is the primary piece of heavy equipment that one uses to build a groundwater dam. Here are the main reasons to build a groundwater dam. Number one, they will restore the historic elevation of groundwater and surface water. Number two, they will saturate the soil in the wetlands and the streams and in the river valleys. And number three, they can be used to repair failed and dry wetlands, lakes, and ponds. This drawing shows a profile view of an emergent wetland built using a groundwater dam. The groundwater dam is located where the natural rim of the wetland was lowered years ago by somebody digging ditches and installing buried drainage structures. Let's study this profile drawing of a typical groundwater dam. Groundwater dams are effective because they, number one, block buried drainage structures made from wood, rock, clay tile, and plastic. Two, they reduce water losses by roots, root channels, and topsoil. Three, they block the water leaving the wetland underground in permeable layers of organics, gravel, sand, silt loam, and loose clay. And four, they block above and below ground movement of water in ditches. And five, they prevent the ditches you cannot block nearby from draining your wetland. And lastly, number six, they allow burrowing crayfish to live in your wetland without draining the wetland. Let's look at where the groundwater dam should be built. Most groundwater dams are built along the lower 2/3 edge of the wetland you're planning to build. The elevation where the groundwater dam begins and ends should be equal to or higher than the elevation of water in the wetland you're planning to build. Here's where a groundwater dam should be built when blocking a ditch to build a wetland. The groundwater dam will block the water you see flowing in the ditch and also the water you can't see that's flowing underground in the ditch. Here's where a groundwater dam should be built when you're building a wetland adjacent to a ditch and you're not able to block the ditch. The groundwater dam will prevent the adjacent ditch from stealing water from the wetland that you're building. It is necessary to dig one or more deep test holes within the area where you'd like to build a wetland to determine whether or not it's possible to build a groundwater dam for your project. Dig the test holes as deep as the machine or the soil auger you're using will allow. Measure the texture of soil by layer. Continue digging to see if there's a thick layer of clay and an impermeable layer of rock near the bottom of the hole. In this photo you see there is an impermeable layer of rock in the bottom of the hole, and this will be a great foundation for the groundwater dam. There's a thick layer of clay in the bottom of this deep test hole. It will also serve as an excellent foundation for the groundwater dam. The groundwater dam being built for this wetland is going to be based on gray-colored soil, which is a thick layer of soil that is very high in clay. The brown-colored soil near the surface is silt loam, and this soil is permeable. You can see where water is pooling in the bottom of this hole. This is a good sign that the clay layer is thick enough and dense enough to serve as an impermeable foundation for the groundwater dam. While there is impermeable layer of rock in the bottom of this test hole, there is not enough clay above the rock to fill the core trench to make a groundwater dam. You can expect yourself as well as the people around you to get nervous and worried when digging the core trench for a groundwater dam. No one is quite certain that they're going to find bedrock that's impermeable or a thick clay layer, and people start second guessing themselves. Are we going deep enough? Is this going to work? Is it really necessary? Please relax and rest assured that the engineering principles behind building a groundwater dam are solid and that the steps are necessary to build a wetland that will succeed. So chill out, relax, enjoy the process, and just rest assured that what you're doing will help you to build a successful wetland. This drawing is a quick guide showing you where it's possible to use a groundwater dam to build a wetland. We're going to use a groundwater dam to build a wetland where there's an impermeable layer of rock that's fairly close to the surface. It is very difficult, if not impossible, to build a groundwater dam where limestone bedrock is found in the bottom of the test hole. See these layers of limestone that we've cut through using the bucket on the excavator? These layers are permeable. They're not a good foundation for a groundwater dam. Another sign that one should not build a groundwater dam at this location is that we don't see any water pooling on the top of that limestone. This shows that surface water is soaking into the ground and under the limestone layer. Here we're using a large excavator to dig a core trench to make a foundation for a groundwater dam on limestone rock. The limestone is in layers with many cracks between the layers. The operator is not able to peel up and remove these thin layers of rock. The teeth on the excavator bucket slide across the surface and they don't dig in for bringing up the rock. We rented a breaker attachment for the excavator, and this was done at great expense so we could break up layers of the limestone rock near the surface. The breaker attachment works like a giant jackhammer to crack large pieces of rock. One must take their time using this tool and not use it as a pry bar or it will break. It's necessary to use the bucket on the excavator to remove each layer of rock as it's broken. We used a second excavator with a bucket to remove the broken rock. This was much faster and much easier than removing the breaker attachment and reattaching the bucket each time the trench needed to be cleaned out. Here's another site where it's not possible to build a groundwater dam. Groundwater has quickly filled the test hole. This shows it won't be possible to place clay in this hole and compact it to make a groundwater dam. The clay that's placed in the water will quickly turn to mud, and we just can't compact it. Observing crayfish chimneys and burrows while designing a wetland project indicates that there's a permeable layer of gravel or soil below the surface. It also shows that it is possible to block this permeable layer with a groundwater dam. The red line shows the location of a ditch that was dug to drain a wetland on the Yakanuki Lower Kootenai Band Reserve near Creston, British Columbia in Canada. The ditch appears deepest where Norm Allard is standing because this is where the ditch cuts through the natural rim of the wetland. We're going to construct a groundwater dam to block the water flowing in this ditch to restore the wetland. The pink-colored plastic ribbons were hung to show the heavy equipment operator the center of the ditch to be filled. This drawing shows why it's necessary to build a groundwater dam when disabling and filling a ditch. The groundwater dam is needed to block the large amount of water flowing underground in the ditch. The subsurface water is traveling in organics and topsoil that have partially filled the ditch over time, and there may be drainage structures that are installed in the bottom of the ditch or along the edge of the ditch. The excavator operator is digging a core trench across the ditch to build a groundwater dam. The thick black colored layer of organics near the surface is permeable, and this will be interrupted by the groundwater dam. The orange colored plastic flags show the excavator operator where to build the groundwater dam, and this groundwater dam is needed to disable the ditch that's shown by the red dashed line. The excavator operator begins the process of building a groundwater dam by removing vegetation and topsoil from the ditch to be filled. Plants and topsoil are removed from an area approximately 40 feet wide on either side of the ditch. Reed canary grass and its roots are removed from the area where the ditch will be filled. This topsoil and the reed canary grass will not be placed back in the restored wetland because we don't want it to grow. The next step involves building a groundwater dam at right angles to the ditch. The ditch is shown by the red arrow. The purpose of the groundwater dam is to control the water in the soil beneath the ditch and the flow of water in the ditch. The groundwater dam is built where the natural rim of the historic wetland was located. The pink wire flags show the operator where to begin and end digging the trench for the groundwater dam. The trench is being dug about 5 feet wide. You can see the roots that were severed by digging the core trench for the groundwater dam. See how the excavator has cut through the reed canary grass and its roots and down into the clay? I stay on site 100% of the time and carefully watch as the excavator operator digs the core trench for the groundwater dam. I watch and I guide the operator to ensure that we are digging deep enough into an impermeable layer, and the soil that we're using to build the groundwater dam is high in clay. The core trench is dug deep into a dense layer of clay that will form the foundation for the groundwater dam. Soil that is high in clay is piled on one side of the trench for placement back in the trench to build the groundwater dam. I want to warn you that no one, including yourself, should ever enter the trench that's being dug for the groundwater dam. People die each year because the walls cave in and bury them, and this only takes a fraction of a second to occur. Soil that is low in clay, including organics, are piled on the other side of the trench. This soil will not be placed back in the trench. The excavator digs the trench across the width of the ditch and keys it into higher ground on either side of the ditch. Soil that is high in clay is placed in the core trench in 6-inch thick layers, which each layer being compacted using the bucket on the excavator. It takes time to fill the trench with clay and to compact each layer of clay. Most of the clay needed to fill the ditch is obtained by digging a borrow pit on higher ground near the wetland we're building. The excavator operator uses the weight of the machine to compact the layers of clay placed in the trench to form the groundwater dam. We're watching an excavator operator compact clay texture soil in a trench to form a groundwater dam. Layers of soil, only 6 inches thick, are being placed in the trench, with each layer being compacted by the excavator. Here the operator is using the bucket on the excavator to compact the soil being placed in the trench. He's being careful to make sure that all the soil placed in the trench is compacted before adding another layer on top. Here the dozer operator pushes clay towards the excavator for placement in the trench to make the groundwater dam. It is much faster for the dozer to push the soil compared to using the excavator to move it one bucket at a time. The excavator operator is compacting saturated clay soil in the core trench to make another groundwater dam. The soil needed to fill the trench for the groundwater dam is being removed from the wetland basin that's being dug. The operator must be very careful not to get stuck in the mud. This photo shows a different project where a ditch was blocked using a groundwater dam. The dozer operator is now restoring the rim of the natural wetland by building a low dam with gradual slopes over the groundwater dam. The excavator operator is finishing the construction of the groundwater dam that was used to block the flow of water in the ditch. The dozer operator shapes a naturally appearing basin and a rim for the wetland while supplying the excavator with additional clay needed to fill the ditch. The ditch has been filled and the natural rim surrounding the wetland basin has been restored. Restoring the rim involves building a short section of dam on top of the groundwater dam. The above ground dam will be only 20 inches high and it will have slopes of only 5% or less. This photo shows the finished wetland basin. You'll see this yellow flower, it's called bidens. We didn't disturb it because it has great value to pollinators. Here's how the wetland appears 1 year later. Here's how the borrow pit that we dug to obtain soil for filling the ditch appears 1 year later. The process of disabling buried drainage structures is a lot like building a groundwater dam. One must first remove all the clay tiles or the entire length of buried plastic drain pipe. People have told me that all you have to do is to plow up the clay tile and simply crush them in place. This is ridiculous. Landowners purposely bury drainage structures so they are below the plow zone. Crushing clay tiles and leaving them in place is just like installing a rock drain where the water can continue to follow the broken tiles underground. Here an excavator operator is removing a buried drain line that's made from clay tiles. The ditch is going to be filled with soil that's high in clay, and that soil would be compacted using the bucket of the excavator. This is a lot like what we do when we build a groundwater dam. The entire drain line is being removed. This is the most reliable way of disabling a buried drainage system. The clay drain tiles were installed on this hillside with a 6% slope. We were able to drive over this field in two-wheel drive vehicles, even though it was a wet time of year. After we removed the clay tiles and compacted soil in the trench, we couldn't go close to the field in a four-wheel drive vehicle because the soil was now saturated. This plastic 4-inch diameter drainage structure was surrounded with gravel so it would drain. When restoring a wetland, it's best to remove the entire pipe and all the gravel and then fill the trench with clay that's compacted to restore the wetland. I'm now going to take you to the Dix River Wetland and Stream Restoration Project in Lincoln County, Kentucky. This is an amazing project where we use groundwater dams to raise the elevation of groundwater 26 feet over a 72-acre cornfield. The project was so successful that not only did we restore this complex of wetlands, but we were able to take ditches with an intermittent flow of water and then turn them into naturally appearing streams with a perennial flow of water. These groundwater dams work, and I hope you enjoy seeing these photos. While walking around the field along the Dix River, I noticed numerous burrows that were dug by crayfish. What concerned me is that there was no water in these crayfish burrows. The crayfish were foraging in the fields at night, spending the day in submerged water in the bottom of their burrows. The crayfish are adapted to living in the water of wetlands and can survive drought by burrowing into the bottom of the wetlands when they're dry. Crayfish can continue to live in the farm fields that were made by draining wetlands years ago, providing they're able to burrow deep enough to find groundwater. An excavator was used to dig a number of deep test holes in the 70-acre field along the Dix River. The test holes were dug down into the bedrock. We watched and measured soil texture in each test hole that was dug using the excavator. See how the soil near the bottom of the test hole is caving in? This is because the soil near the bottom of the hole is gravel and is saturated, and the brown-colored soil near the surface is silt clay. Here's the gravel that was found below the silt clay in the test holes. The gravel was on top of shale bedrock. The gravel was carrying water, just like an underground river. It was decided that for the wetland and stream restoration project to be successful, we had to interrupt this gravel layer with a groundwater dam, and the groundwater dam must be based on the shale bedrock. The test hole showed us that the crayfish burrows went down to the groundwater and that the groundwater was flowing in the gravel on top of the shale bedrock. The diameter of the crayfish holes averaged 1.5 inches, with an average area of each hole being 1.76 square inches. Crayfish holes were typically spaced 32 inches apart, and this yields an average of 6,000 burrows per acre at the Dix River site. It was estimated that half of the burrows terminated in the gravel, which meant that the burrows had the same effect as an open 7-inch diameter drain pipe for every acre of wetland that would be restored. Actions were not taken to reduce the flow of water down into the holes, into the gravel, and then into the Dix River. There would be little chance the restored wetlands and streams would contain water as planned. The pink ribbons mark the outside perimeter of a groundwater dam that we wanted to build around the lower 2/3 edge of the field. This would raise the elevation of groundwater so the soil in the field would become saturated. Because the field changed 2 feet in elevation from upper to lower edge, we decided to split the field in half and build 2 groundwater dams. Ideally, groundwater dams would be placed every 1 foot change in surface elevation, although I have successfully used them on steeper ground by placing them every 2 foot change in surface elevation. A main concern of the project was not to flood the home and the barn that you can see near the base of the hill. It was determined that building an above-ground dam could flood the home, so we made sure that the elevation of the groundwater dam kept lower than the elevation of the neighboring private land where the home was located. Here the dozer removes topsoil from a 200-foot wide strip that extends inward from the pink flagging that was placed to mark the outer edge of the groundwater dam. Topsoil is piled in a windrow uphill of the pink flags. We would later spread this in the completed wetland. We were removing the topsoil from an area where we would later obtain the silt clay textured soil for building the groundwater dam. The red dashed line shows the center of where the core trench will be dug for the groundwater dam. A large 300 series excavator with a 60-inch wide bucket was used to dig the trench for the groundwater dam. The red dashed line shows the center location of the groundwater dam that we're going to build. The excavator is piling the silt clay texture soil being removed from digging the trench inside of the wetland being built and onto the area where the topsoil was removed. This silt clay will be later placed in the trench in layers, with each layer being compacted after the gravel is removed. Now the excavator is removing gravel from the trench. The gravel is being piled outside of the wetland being built and on top of the ground where the topsoil has not been removed. This gravel will not be placed back in the trench. The excavator moves backwards as the core trench is being dug, so the machine does not have to straddle the deep and the wide trench. The core trench is based on a firm and impermeable layer of shale bedrock that is made wide enough for a medium-sized dozer to enter. Note how water is pooling in the bottom of the trench? This is a good sign. It shows that water is not soaking into the ground. The core trench was dug to be from 18 to 26 feet deep. This close-up photo shows the bottom of the trench being dug. The permeable layers below the brown-colored silt clay are being removed, and they won't be placed back in the trench. The core trench is dug down or keyed into the shale bedrock. This involves removing the upper, softer layers of shale and digging down into the harder layers of shale that will perch water. The groundwater dam was built in sections. This way the walls of the trench do not cave in and there isn't enough time for water to fill the hole. We dug through many buried drain lines when digging the core trench, and these have been placed in different years and in various directions. This photo shows one of the many buried clay drain tile structures that was still functioning. There was a steady stream of water flowing in this drain line. The groundwater dam will block the flow of water in these buried drain lines. Some of the clay drain tiles had unique patches on them, and these were designed to block any wide gap between the drain tiles. Digging the core trench and building the groundwater dam ensured that buried drainage structures were found and disabled. Some of the clay drain tiles were broken and plugged, like what you see here. These may have been laid on a foundation that was too soft, and as they were being covered with soil, they could have settled into the ground. The clay drain tiles were found to be placed in different patterns and at different depths in the large field. This drawing shows some of the various patterns that have been used for placing clay tiles when draining a wetland. One can rarely see in an aerial photograph where drainage structures are located. This aerial photograph taken in Seneca County, New York is an exception. The white lines in the agricultural field show where drainage structures have been buried. The white color shows where the soil has the lowest moisture content, and this is directly above each drainage structure. Here's another aerial photograph taken in Seneca County, New York, and again you can see where the buried drainage structures are located. I want to emphasize how rare it is to be able to spot buried drainage structures in an aerial photo. However, these photographs should give you an idea of the high number and the high density of structures that are used to drain wetlands. This is why it's of critical importance that you dig a core trench and build a groundwater dam for every wetland project that you design. Plastic drain lines like this 4-inch diameter slotted pipe were also found when we were digging the core trench for the groundwater dam. Farmers began using plastic slotted drain pipe to drain wetlands in the 1970s. 4 buried drainage structures that were constructed from using tree trunks were found while building the groundwater dam. These log drains were fully functioning and carrying large amounts of water even in a drought. Here's a close-up photo that shows one of the log drains that was buried 8 feet underground. The log drain ran the entire length of the field. The logs were perfectly preserved and the water was still flowing underground in the spaces between the logs. This core trench is not being dug deep enough. It must be dug to the bottom of the crayfish burrows that are visible in the trench, or the crayfish that are hidden in the bottom of the hole can dig new holes up to the surface and drain the wetland. We found that crayfish will not dig their burrows in the clay that is compacted in the core trench to form a groundwater dam. The excavator cuts through and removes the soft upper layers of bedrock until a firm, less permeable layer of rock is reached in the bottom of the core trench. The thick gray color layer is shale bedrock. The rusty color overlaying the shale is sand. Note that there's no gravel in this section of the trench. The gravel was in layers of different thicknesses. It was deposited over the bedrock in mounds or waves, much like one sees in a stream channel. The groundwater was not flowing in the silt clay. However, the groundwater was flowing in the stream channels that were underground, and these were in gravel overlaying the shale bedrock. Here the excavator fills the very bottom of the trench with silt clay to avoid a cave-in. Some sections of the trench were so unstable that one could not leave it open long enough for the dozer to spread a soil layer in the bottom. The excavator operator moves quickly to place soil in the bottom of the trench before gravel caves in from the sides or water flows in and makes mud that can't be compacted. I stood on high ground overlooking the trench and alerted the operator when there was a cave-in so the gravel could be removed before the trench was filled with soil. Leaving gravel in the trench would have had the same effect as installing a drain pipe that would bypass the groundwater dam. The bucketed excavator is being used to compact the silt clay soil in the very bottom of the core trench. The excavator is reaching down into the ground 25 feet in this photo. A smaller 100 series excavator was used to help fill the bottom of the core trench. To avoid cave-ins of gravel, the operator of the small excavator would reach up and pull down the top portion of the core trench that was silt clay soil. The heavy equipment operators worked very well together and they built a high-quality groundwater dam, and they were very careful to avoid collisions. Where the gravel walls in the bottom of the core trench were high and collapsing, the small excavator would fill the core trench as soon as the large excavator had cleaned it down to bedrock. Water would also fill the core trench. The water was removed using the bucket on the excavator so the soil could be placed and compacted. The operation required close coordination between everybody who was involved to make sure that the gravel was removed before the core trench was filled and compacted with silt clay soil. Here it looks like the small excavator is almost building a road in the bottom of the core trench. The silt clay was compacted to an elevation above that of the gravel and the sand in the core trench, which were more likely to collapse. The operators of both excavators kept watch to make sure the gravel was not buried in the trench. If the gravel and sand were observed, they were removed and then they were replaced with silt clay. I was on site every day working with the heavy equipment operators to complete this project. The dozer operator is pushing silt clay soil towards the excavators that will be placed in the bottom of the core trench. The dozer operator travels back and forth and from left to right to compact each layer of soil that's placed in the core trench. The trench was dug wide enough for the dozer operator to move the machine from left to right to compact even the center of the soil that was placed in the trench. It's of great importance to have at least one large excavator and one large dozer working together to build the groundwater dam. The excavator is used to dig the trench and to sort soil by texture. The dozer has many jobs, from removing and spreading the topsoil to supplying the excavator with clay and then spreading the gravel that's removed from digging the trench. The dozer shifts positions from left to right to obtain compaction over each layer of soil that's placed in the trench. The dozer continues to add and to compact layers of clay to build up the groundwater dam to the planned elevation. The next step will be for the dozer to spread large piles of gray-colored gravel that was removed from building the groundwater dam. Crayfish will not burrow in the completed groundwater dam because this clay is compacted and there's no groundwater present below the groundwater dam. The dozer is spreading the gravel removed from building the groundwater dam. Both the dozer and the excavator are spreading the topsoil that was saved over the clay in the finished groundwater dam and over the gravel that was spread. Shallow depressions of various depths were dug over the field after the groundwater dam was completed to restore both emergent and ephemeral wetlands. The success of the groundwater dam can be seen by groundwater rising in the basin as it's being dug. Shallow water emergent and vernal pond wetlands with natural contours, including pit and mound topography, were restored in the large field that had been filled and leveled for drainage. Here an oxbow-shaped emergent wetland is being restored at Dix River by moving frozen soil. The technique worked well as the soil could not be compacted because it was frozen. We did not want to compact this soil because these wetlands were designed to collect runoff and then to inject this runoff into the ground. You can see how the site is holding water 1 month after construction. This is one of the many wetlands that was built 1 year after construction. Here's one of the many emergent wetlands that we restored at Dix River. American lotus, which is a native species, was planted in this wetland. Wet meadow wetlands have developed in what was a cornfield for many years. You'll find signs that crayfish are thriving at Dix River. Although their burrows extend down into a permeable gravel layer, they cannot drain the large restored wetland area. This is because the groundwater dam, which surrounds the lower 2/3 of the field, interrupts the gravel layer and holds water on the site. Please stay with us on this video because now we're going to look at how you can build a wetland like this one here and base your groundwater dam on a thick layer of clay instead of bedrock. The technique works. It's very important to determine if that deep layer of clay is going to be a good foundation for the groundwater dam. The dense clay you see in the soil auger was brought up from 10.5 feet below the surface. This thick layer of clay would make a great foundation for a groundwater dam. This long and thin ribbon that we formed from the soil in the auger shows that it's very high in clay. Here a dozer is being used to remove the topsoil from an area where the groundwater dam will be built. The topsoil is pushed into a long pile we call a windrow for later placement in the finished wetland. The dozer removes topsoil from an area about 200 feet wide that includes and parallels the location where the core trench is going to be dug for the groundwater dam. Orange wire flags are placed in the ground to show the excavator operator the center location of the groundwater dam we're going to build. The excavator operator begins by digging a trench for a groundwater dam. The trench is dug below the depth of any crayfish burrows that are present. Topsoil and organic material that are removed are placed on the right side of the trench. The soil that's high in clay is placed on the left side of the trench. We'll place this clay back in the trench to form the groundwater dam. It's very important to stand by and to watch carefully as the excavator operator digs the core trench for the groundwater dam. This is because the operator has trouble seeing the bottom of the trench and would appreciate your assistance in deciding what soil to remove and what soil to save to build the groundwater dam. I've had so many people tell me over the years that you don't need to build a groundwater dam to make a wetland. They often ignore my advice and build a wetland without a groundwater dam. Then they're surprised and embarrassed to find that they've wasted thousands of dollars to build a big, dry hole in the ground. Let's look at why groundwater dams are needed. The vertical face of this trench dug for a groundwater dam shows that the soil is high in clay. However, if you look closely, you'll see lenses of silt loam soil and roots, which are all permeable. This will cause the wetland to fail unless their path is blocked by a groundwater dam. Jason Jennings, a soil scientist with the U.S. Forest Service, is examining a sand lens that is surrounded by clay that we exposed while digging the core trench for a groundwater dam. The clay we're planning to place in the core trench to build the groundwater dam will block the sand lens so the wetland will hold water. The person's hand is pointing to an underground stream that's flowing in a collapsed drainage structure that was made from clay tiles. This structure was exposed by digging the core trench for a groundwater dam. The groundwater dam we're building here will block water flowing in the black-colored topsoil near the surface and in a buried layer of topsoil that's beneath the surface. Here is where a core trench has interrupted a buried drainage structure that was made from rock. This is a rock drain that was made with gravel. It measured exactly 12 by 12 inches, and we exposed it while we were building the groundwater dam. Miranda Cross is standing over a still functioning wood drain that we exposed while building a groundwater dam on Cortes Island in British Columbia, Canada. Here's a buried drainage structure we uncovered while building a groundwater dam in the desert near Portal, Arizona. This wooden drain would have caused the wetland we are building to fail had we not dug the core trench for the groundwater dam. You can see water collecting in the bottom of a core trench that we dug for building a groundwater dam. The water is flowing out of a hole filled with loose soil in the side of the core trench. This hole may have been made by someone using a mole plow to drain a wetland years ago. Well, here's a real problem. The thick layer of gravel was exposed when we were digging a core trench for a groundwater dam. The gravel was shaped like a stream channel that had been buried years ago. There is no way the wetland would have held water without building a groundwater dam at this location. Water is flowing in this buried clay tile line that we cut while building a groundwater dam. It's often necessary to dig quite deep to remove gravel when building a groundwater dam. This is why it's important to have an excavator on site that weighs at least 48,000 pounds with a minimum of 138 horsepower. You're looking at the bottom of a core trench that was dug and left open overnight. A crayfish has opened its burrow that was blocked by the dozer digging the day before. It's necessary to dig the core trench much deeper to the bottom of the crayfish holes and then to fill the trench with clay that's compacted in layers if we want the wetland to hold water. It's often necessary to fill and compact the bottom of the core trench using the excavator when it's dug deep like this one. For safety reasons, heavy equipment should not enter the trench where a cave-in could cause them harm. Here the dozer begins to widen and fill the core trench that was dug by the excavator. The excavator dug the core trench about 3 buckets wide, and it went really fast. Because the sides of the core trench are clay and not gravel, the dozer can quickly widen the trench by collapsing the walls, and then it can spread and compact the soil in layers to make a groundwater dam. The dozer has widened the core trench so it could travel back and forth and side by side to spread and compact the clay to form a groundwater dam. The dozer spreads, levels, and compacts the layers of clay soil. Compacting layers of soil to make the groundwater dam takes time, but it's worth it. The dozer operator is very efficient in placing and spreading clay in the trench to make the groundwater dam. The process of adding and compacting clay in layers continues until the groundwater dam is built to the planned elevation. Both the excavator and the dozer are being used to compact soil in the upper layers of this groundwater dam. When a dozer is not available, you can use an excavator to place and compact the soil in a core trench. The clay texture soil that's removed from digging the trench is mixed using the bucket on the excavator and then returned to the trench and compacted in layers to form the groundwater dam. Here the excavator is using its bucket to compact a layer of soil that was placed in the core trench. This process takes time and it's less efficient than using a dozer and an excavator. The action of compacting soil with a bucket of the excavator involves repeatedly raising the bucket of the machine up and down and pushing it with force into the ground. This will shake, rattle, and jar both the machine and the operator and can eventually damage the excavator and possibly harm the operator. This is why I try to limit the length of groundwater dam that I ask an individual to build by using an excavator alone to less than 100 feet per day. The groundwater dam is dug in sections. The excavator is beginning to dig a new section of the core trench by digging into the end of the groundwater dam that was completed the day before. Wire flags were used to mark the end of where the groundwater dam was completed the day before, so the next day the excavator may dig a hole that connects with the section that was completed earlier. The groundwater dam is built in sections. An open trench should not be left for any length of time, or it could be a hazard to both humans and animals. Another problem is that the open trench may fill with water or cave in. The excavator is completing the construction of a groundwater dam. The soil was placed in the core trench and compacted in layers using the excavator's bucket and tracks. The windrows of soil you see on the left are primarily topsoil that will be spread over the groundwater dam and in the wetland basin. Now the dozer operator is digging and shaping a shallow wetland basin. The soil that's being removed will be placed over the groundwater dam to restore the natural rim of the drained wetland. The dozer operator shaped a shallow basin for the wetland. The next step will be to spread topsoil over the completed groundwater dam. I would like to address the main questions I get asked about building a groundwater dam. The first question, what can I do if I can't find enough clay to put in the core trench? It's okay to use any soil texture other than sand, loamy sand, or gravel to build a groundwater dam. However, it's very important to mix the soil before placing it into the core trench and compacting it in layers. What's of greatest importance is that you interrupt the permeable layers of soil that are currently carrying water underground. Question number 2. Will the groundwater dam cut off the flow of groundwater in the valley? No, this won't happen. A groundwater dam will restore the historic elevation of groundwater in the valley by blocking drainage structures that farmers installed years ago. The restored wetlands will capture surface water runoff and inject this water into the ground. What is important to recognize is that water is flowing underground at various elevations below the surface, and that the groundwater dam you're building will restore the elevation of the uppermost water table. Think of how when you drill a well, the well taps water in a deep layer of groundwater that is far below the surface. The groundwater dam only affects the uppermost layer of groundwater. Third question, what should I do if I can't reach an impermeable layer of clay or bedrock that will serve as a foundation? First of all, try moving the groundwater dam uphill or away from the stream to get out of this sand or gravel. If this isn't possible, then you may need to change the technique for building the wetland. Use the groundwater technique to build the wetland if the water is filling the hole that you're digging. Use the compacted clay liner technique if there's a thick layer of clay near the surface. However, you may need to use an aquatic safe liner if there's no clay and no groundwater that's present. Groundwater dams work. You're looking at some of the thousands of wetlands I've built using groundwater dams.
The groundwater dam technique is the lowest cost and it's the most effective way to build a wetland that looks and functions like a natural ecosystem. Please try to use this technique wherever it's possible. I'm Tom Biebighauser. This is Wetland Restoration and Training. Please share this video with others, mark that you like it, and subscribe, and we'll see you with the next episode.